In 10.2, we start to explore chords and chord properties. We want to recall that chord is any time that we have a line or a line segment where we have the start and stop of the line are sitting on the edge or the outer circumference of the circle. So our chord properties tell us that if we have a chord, if we have a line where the start and stop is on the edge of the circle, that if a line passes through the center of that chord, and in this case, I try to draw the chords as purple. If a line passes through the center of that chord and that new line passes through the center of the circle, then that line from the center of the circle to the edge will become a radius, and that radius will have bisected or cut in half at a 90-degree angle at a perpendicular angle, creating a perpendicular bisector. So let's take a look at our 8.2, our 10.2, show you knows. So in 10.2, we see our first show you know chord property asks us, looking at page 387 of the student textbook. So in this question, we get told that the radius CH bisects chord FG. So we can see that our radius, I will do our radius here as green. So our radius, which is line CH, is bisecting or is splitting in half the chord FG. And we can see that FG is purple. It's been split into two equal halves marked by those two congruency markers. And because this chord has been bisected or split in half with a line that passes through the center of the circle, we also should recognize that that means that it was not only split in half, but it was split in half at a 90-degree angle. So now we know we've got a 90-degree or a right angle. We know that the radius measures 10 centimeters. So we know that from point F to J is 10. We know that from point C to H is 10. So I'm going to mark that radius as being 10 centimeters. And again, that's our radius line is from C to H. I can also see a radius line from C to G because again, that's from the center of the circle through to the outer edge. So I can see that that line measure is also going to be 10 centimeters. We also got told that line FH, our chord, our purple chord, is 12 centimeters. So if FG was 12 centimeters, but it's been split into two equal congruent halves, FJ as well as JG, we know that both of those are going to be half of that 12, or that both of those are going to measure 6 centimeters. We are being lastly asked, what is the length of line CJ? So if I was to pull out my triangle here, I can see that I've got point C, the center of the circle. I've got point J, and then over to the right, I've got point G. So we know that this line JG is part of the chord, is 1/2 of the chord, and that measures 6. We know that that line CG is going from the center of the circle to the outside edge. So we know that that's a radius, which means that it is using the given radius of 10. And we are being asked, what is the length of line JC? And in this case, we can think about this as our unknown for what we want. So now we're looking at a right angle triangle. And so we want to be thinking about our right angle triangle rule is Pythagorean theory, which states, of course, that a squared plus b squared is equal to c squared, where c squared is always the hypotenuse or the longest. And that can be rearranged as the hypotenuse squared minus a known arm or leg squared is equal to the unknown. So we're going to use this formula here, where what we are isolating for is the arm of the triangle. So in this case, we're going to now plug in or substitute our known values. We know that our radius is equal to 10. So we've got 10 squared minus our known arm is 6 is equal to a squared. This means that we have 100, which is our 10 squared, minus 36, our 6 squared. 100 minus 36 is going to leave us with 64. And if we know that 64 is our a squared, then square rooting that is going to give us the value of our line JC or CJ. And here we should recognize that we are coming back to the value of 8 centimeters. So lastly, we would finish with line CJ equals 8 centimeters, and just clearly wanting to provide an easy to follow answer. Taking a look at the second show you know from 10.2. In this question, we're being told that Mark would like to plant a cherry tree in the center of a circular flower bed. Explain how he could identify the exact center using circle properties. So where is it, how is it using chord and circle properties that we can determine the center? Well, if we recall the second set of chord properties that we spoke of earlier, we realize that if there are two unique chords, so step one, so first, draw or identify, perhaps recognizing this is a garden, two distinct or separate chords. Second, find the halfway point or the center. And then from the centers, from the two centers, bring a new line. And the point of intersection would be the true center. So thinking about what does this look like? So if I was to draw chord AB and chord CD, then I would find, sorry that these lines are changing or circles are changing. I would find the center point of each. Okay, so again, we're determining center. First, we create two chords, create two distinct chords. Then using those two chords where the centers have been marked, we are going to draw towards the center of those two circles. Again, using new lines. And that is the 10.2 show you know.